Okay, today we're going to look at some problems from section 5.2 in our textbook, properties of rational exponents and radicals. And so our directions are to simplify, and it says use absolute value signs when necessary. So here we have the square root of this expression. So I'm going to split it, square root of 50, square root of x squared, square root of y to the fourth. Okay, so square root of 50, we're looking for a factor that's a perfect square, and the largest one if we can find it, which is 25. The square root of x squared we know is the absolute value of x. And technically, one way to look at the square root of y squared, or y to the fourth rather, is the square root of y squared times the square root of y squared. So we have 5 root 2 absolute value of x, absolute value of y, absolute value of y. So absolute value of y times the absolute value of y is y squared. And because y is being squared, it's always positive. We don't actually need the absolute value. So we would have 5y squared, absolute value of x, and then root 2. Okay, here we have the cube root. So again, I'm going to split it. So the cube root of 375. And then instead of writing cube root, I think that there's an advantage with our variables to using fractional exponents. So here I'm looking for a factor that is a perfect cubed. And I know that's going to be 125. Okay, so now I have x to the 6th raised to the 1/3. Power to a power we multiply. 6 times 1/3 is 2. And because we're taking an odd root, we don't have absolute value. And then we have y to the 7/3. And then from here, we're going to reduce this, and I'm going to deal with this. So cube root of 125 is 5. Then I have the cube root of 3. Then I have x squared. And so this is the same as x to the 6/3, right, times x to the 1/3, right, because we would add our exponents. Well, that's y squared. So now I'm going to have a 5x squared y squared. Right, there's your x squared, there's y squared. So we have a cube root of y and a cube root of 3, and we would write that as the cube root of 3y. Okay, so moving on here, we're going to simplify. We're going to rationalize our denominators. So we have a square root here, so we're going to multiply the top and the bottom, the numerator and denominator, by the square root of 5. So we can multiply in because they're both the same radical, same root. The denominator, technically we get the square root of 25. Well, we know that's 5. 5 divided by 5 is 1. So we're left with the square root of 15. Okay, so moving on, we've got a couple of things that we could do. I think it's actually easier, since we have square roots in the numerator and denominator, to see if we can simplify before we rationalize the denominator. So I notice I have an n to the 4th and an n to the 4th. That divides out and equals 1. And so technically that's not a cube root, that's a 3. So I have 3 now times the square root of 5, and then the denominator, the square root of 2, because our n to the 4ths divide out, that equals 1. So rationalizing, I multiplied the numerator and denominator by root 2. We get the square root of 10. Square root of 2 times the square root of 2 is 2. Okay, pretty straightforward so far. A little bit more complicated here. We've got a few more terms, and now we're looking at a cube root instead of a square root. And again, I like to simplify this. And so for visually, so you see what's going on, I'm going to write this using our rules of radicals, since they're both cube roots and we're dividing. So I'm going to see what I can divide out. So there's no common factor between 2 and 25. I have an x in the numerator and x cubed in the denominator, so that's going to leave me with an x squared, and the y squareds divide out. So now, separating it out again, I have 5 times the cube root of 2, and in the denominator 4, the cube root of 25x squared. All right, so now the denominator, in order to rationalize, needs to be perfect cubes. So remember, perfect cubes are numbers like 1, 2 cubed 8, 3 cubed 27, 4 cubed 64, 5 cubed 125, 6 cubed 216, right? We can keep going. Okay, so I know the next perfect cube that is a factor, that has 25 as a factor is 125. So I need to multiply that by the cube root of 5. And then to get this to be the next perfect cube, I have to multiply it by x. And again, whatever we do in the numerator, we're going to do in the denominator, or vice versa, rather, because that's the denominator. So again, both cube roots, so we're going to be able to multiply. So we get 10x. And then in the denominator, what we have is 125x cubed. And now we can do what we did in the previous page. Nothing is going to simplify in our numerator. But in our denominator, we have 4. The cube root of 25 is 5. Cube root of x cubed is x. The 5's divide out. And we're left with the cube root of 10x divided by 4x. Okay, again, moving over here, we notice we have the 2's. They divide out. I have a negative in the numerator. I'm actually going to write that as the cube root of -1. And then we have 9 u to the 4th v, and in the denominator 12 u squared v cubed. Again, that's all cube root. Okay, so the cube root of -1 is -1. 3 divides into 9 3 times, into 12 4. So my numerator, I'm going to have a cube root of 3, and in the denominator, I know I'm going to have a cube root of 4. I have a u to the 4th divided by u squared. That leaves me with a u squared in the numerator. And v divided by v cubed leaves me with a v squared in the denominator. So a little bit more than I need right here. Okay. So now again, I'm looking for the next perfect cube. So 4 divides into 64, that's 16 times. So I'm the cube root of 16v. And the v, because v times v squared would be v cubed. So they would be your perfect cube there in the denominator. So -1. Oh, my mistake. I don't know if anybody saw that. The next cube actually from 4 is 8. I don't need to go all the way to 64. I could, but then I'm going to have to do more simplifying. So I'm going to change that. So in my numerator, I'm going to have the cube root of 6 u squared v. And in the denominator, I'm going to have the cube root of 8v cubed. So the numerator stays as 6u squared v. That's going to be 2v. If I had done the 16, I would have ended up with 48 in the numerator, and then I would have had to recognize that there was a perfect cube as a factor that would have been 8. We would have had to factor that out. So always advantageous to find the largest perfect cube if you can. All right, so moving over here now, again, we're back to square roots. So I think it's advantageous to simplify. And I'm going to do this without writing it all out, because I think we've hopefully progressed to the point that we can do that. So in our numerator, right, there's no common factor between 5 and 3. M cubed over m to the 4th is going to leave us with an m in the denominator. N squared divided by n to the 4th will leave us with an n squared in the denominator. So a little bit more than I need there. Okay, I have the square root of n squared. So that's the absolute value of n. So 5 absolute value of n divided by 3m. So again, square root. So I'm going to multiply the numerator and the denominator by the square root of 3m. In our numerator, we can multiply. We get 4 and then the square root of 15m. In our denominator, The square root of 3 times the square root of 3 is 3. 3 times 5 is 15. I have the absolute value of n. And then the square root of m times the square root of m is the square root of m squared, which is also the absolute value. And I can put them in the same absolute value sign. So notice earlier we were rewriting it all under one radical. Now, in essence, it's what I'm doing without having to write it all out. So hopefully you start to make that transition that you don't have to do this. But if you have to still, that's fine. Nothing wrong in that. So again, here we have perfect cubes. So I'm going to try to simplify this numerator and denominator without writing it all under one radical. So looking for a common factor between 6 and 50, and that's 2. So that will leave me with a 3 and a 25. X squared divided by x cubed leaves me with an x in the denominator. Y squared divided by y leaves me with a y in the numerator. Okay, again, perfect cubes, be 125 rather. And then x cubed, so I'm going to multiply the top and the bottom, the numerator and denominator, by 5x squared. In my numerator, cube root 15 x squared y, denominator cube root 125 x cubed, and now we have the cube root of 15 x squared y, and in the denominator we have 5x. Okay, so hopefully we're good so far. Okay, just a couple of more problems that we're going to look at here. So here, instead of dividing, we're multiplying, but again, we use the same rules we can multiply through. So square root, 6 times 15 is 90. M cubed times m cubed is m to the 6th. So we have the square root of 90 times the square root of m to the 6th. Okay, moving on. So now we're going to split this into the square root of 9 times the square root of 10. That's the biggest factor of 90. That's a perfect square. And the square root of m to the 6th, we could also write as m to the 6th to the 1/2. Power to a power, we multiply. Even root of an even power is going to leave us with an absolute value. M cubed. Square root of 9 is 3. 3 absolute value of m cubed times the square root of 10. All right, so over here, we'll have the cube root multiplying through because they're both cube roots. Negative 48 v to the 6th. So splitting this up, we have the cube root factor of negative 48, that's a perfect cube, is negative 8 times the cube root of 6. And then v to the 6th to the 1/3. And again, which is the cube root of v to the 6th. So the cube root of negative 8 is negative 2. V to the 6th to the 1/3 is v squared. And then we're left with the cube root of 6. Okay, last couple of problems. Notice it says to simplify. And now it has some restrictions on our answers. Only positive exponents and no fractional exponents in the denominator. So a lot going on here with these two problems. What I'm going to do first here is I have a power raised to a power. So we're going to multiply and we can distribute because inside our parentheses we're multiplying. So we have a negative 1/2 times 3 is negative 3/2. And then b to the positive 3/2. In our denominator, notice we have an a to the 3/2 times an a to the negative, or 3/4 rather, and an a to the negative 3/2. We're multiplying like bases, so we're going to add. So we have 3/4. Common denominator would be a negative 6/4. And so 3/4 plus a negative 6/4 is negative 3/4, and then we have a b to the 1st. Okay, so now we're dividing like exponents, so we subtract. So we have a, this would be negative 3/2 minus a negative 3/4, and then b, we would have 3/2 minus 1. Okay, so minus a minus is a plus. So that's becomes a plus, and 3/4. 3/2 converted would be -6/4. So that gives us a to the -3/4 times b. And again, we're subtracting. 3/2 minus 1 is 1/2. Negative exponent tells us to take the reciprocal. So this is a good answer, except for our restrictions. Okay, only positive exponents, so we flip that to the denominator because of the negative, but then it says no fractional exponents in the denominator, which is what we have. So that means all exponents in the denominator need to be integers. So we're going to, or actually in this case, whole numbers. So we're going to multiply this numerator and denominator by 1/4. Because notice, multiplying like bases, we add the exponents. That's going to give us 1, which is a whole number. So we have a to the 1/4 times b to the 1/2 over a to the 1st. Okay, so over here, I've got multiple like bases inside my parentheses. So I actually think it's easier to simplify that before multiplying to the -3/2. Okay, so I have a y to the 1st and a y to the -1/2. We add those exponents and we get 1/2. I have an x to the 1/2 and an x to the -2/3. So adding that, just to show you over here, we have a 1/2 and plus a -2/3, using a common denominator of 6. That would be 3/6, and then 2/3 minus 4/6. So you would get x to the -1/6. All raised to the -3/2. And then in the denominator, there's nothing for us to simplify yet. So we have an x to the 5/3 and a y to the -1/2. Okay, power to a power, we're going to multiply. So 1/2 times -3/2 is -3/4. -1/6 times -3/2 is -3/12, which is also the same as -1/4, and then we have x to the 5/3 and a y to the -1/2. Okay, again, power to a power, we're going to, we're dividing like bases now, so we're going to subtract. So the y's, we have -3/4 minus a -1/2. And then the x, we have a -1/4 minus 5/3. Okay, so minus a minus becomes a plus. Common denominator, that's going to be a 2/4. -3/4 and 2/4 is -1/4. Here, I'm going to need a common denominator of 12, right? So 4 divides into 12, 3, so that's -3. 3 divides into 12, 4, so that's going to be 20. Let's see here. Let's see, what's my mistake? I think that's a positive 1/4. Let's go back here. Yep, that should have been, right? Because that was a negative times a negative. So I don't know if anybody caught that as I was going through that. Right, negative here times a negative, that should have been, in that multiplying, a positive 1/4. So that leaves us with x to the -17/12. Okay, so both negative exponents, so that means they go in the denominator. So we have 1 over y to the 1/4 x to the 17/12. Okay, so now we need these to be integers. So the next integer above 1/4 is 1. So I'm going to multiply by y to the 3/4, right? Because we add our exponents. The next integer above 17/12, which is 1 and 5/12, is going to be 24/12, or 2. So I need to multiply that times x to the 7/12. Excuse me there, let me get the light back on. All right. So our numerator will be y to the 3/4 x to the 7/12. And in the denominator, that becomes y to the 1st x squared. All right. Hope that helps, and we'll see you real soon.